Hello everyone, welcome you all again to the fast review course on Foundation Engineering in accordance with the MAPOT syllabus. Today in the second lecture we will start the file foundation and basically we will cover in this lecture the classification of the file foundation. I am Dr.Souvik, Patra, Assistant Professor in the Department of Civil Engineering, Swami Vivekananda Institute of Science and Technology, Kolkata, and these videos lectures are prepare for the YouTube channel Mission Career 3104 initiative by the Swami Vivekananda Institute of Science and Technology. Now, if you want to classify the pile foundation, we can classify it with multiple category. That's mean how the load is transferred to the subsoil. It's based on mechanism, how the material used, or the shape or its cross section. So basically, we classify pile foundation mainly on six category: the function or the load transfer mechanism, material used, method of the installation, displacement of soil, shape and cross section, and user application. So the first one is the function or load transfer mechanism. That's mean that how a pile, suppose I have a pile here, and how the load coming from the superstructure it's transferred to the subsoil. Based on the load transfer mechanism, we can classify pile foundation in mainly three category, that is end bearing piles, friction piles, and combined of the both the effect end bearing and friction piles. In end bearing piles, what we are doing that the load is transferred directly to the farm stratum. Suppose I have a the structural load is coming from that is the Q, that the superstructure load, and that is the pile, that's the length of the pile L, and here a rock stratum or the hard stratum is present. So we are transferring the superstructure load through the structural element pile to the directly to the hard stratum. So this is known as your end bearing pile. So in this case, transfer loads directly to the strong bearing hard stratum. It acts like a column. Tip of the pile rests on the firm strata like rock. So like in this case, this is the pile and it is resting on the hard stratum, and the load is transmitted through the tip. So that means that is the tip of the pile. This is known as the tip of the pile, and the load is transferred through this tip to the rock stratum. Example, we can say that pile resting on bedrock beneath the loose soil, and it is mostly effective. Suppose in this zone if the soil is too loose or the bearing capacity of the soil is less, so in that case we can use the end bearing pile and transfer the load directly to the hard stratum. The second category is your friction pile. In this case, suppose this is my pile foundation, this is the ground level. In this case, suppose the hard stratum is situated at a very great depth. So in this case, what we are doing that some soils are present around this. So in between soil and the outer diameter of the pile, there is some friction will develop, and basically we are using this friction as a load transferring mechanism. So this kind of friction piles basically used, but when no farm stratum is available, that's mean the rock stratum is situated at a very great depth, and if we construct a pile to the rock stratum, it will be not economical, and the material and the material cost and the construction cost will be much more higher, and the load is transferred through the skin friction between the pile surface and the surrounding soil. So this is the surface of the pile. It's a cylindrical structural element, and along the surface of the pile and with the soil present, that's the soil present surrounding to the pile. So in between there is a frictional resistance will develop. That's mean if the load is coming from the superstructure Q, so it will try to penetrate the pile below. So if the pile try to go downward, then a upward resistance force will develop along the surface of the pile. So this is known as the skin friction. So we basically use this skin friction to transfer the load, and it typically used in soft soil of large depth, for example timber pile in clay soil. And the most economical or the practical application of this load transfer mechanism of pile is combining both the end bearing piles and friction piles. So in this case we are basically using the skin friction, the skin resistant part, and the end bearing resistant part. So if the end bearing resistant part is QB and the skin friction resistance part is QA, so we are to get the ultimate bearing capacity will get as the end bearing plus the skin friction resistance. So it is more economical and it is the most practical to use in field. So the part load is transferred by the tip and part by the skin friction. That's mean if the total load is Q, this Q is superstructure load will be subdivided in two way. The partly the load will be carried by the skin friction QF, and partly the load will carried by the bearing. So there is also the hard stratum is not present, but the soil present in this zone, it will also offer some resistance. So that is the end bearing. So depending on the load transfer mechanism, we can classify piles mainly in three categories: end bearing piles, friction piles, and combination of this end bearing and the friction action. Now, based on the material, we can classify pile. Generally, in pile, we generally use materials. These are basically timber. It may be bamboo for micropiles. It may be concrete, steel, or composite. That means it may be combination of the concrete and steel. So depending on the material, we can classify pile as a timber piles, concrete piles, steel piles, and composite piles. So timber piles, it is used for temporary works on waterlogged areas, must be treated against decay. That's mean timber is an organic material, so with time it will decay. So we need to consider some or we need to treat the timber so that it will act against the decaying of the wood, so that we can get the longevity of the timber pile can be enhanced. Now, concrete pile, it is basically precast or cast in situ, suitable for heavy load. Precast means the pile is earlier casted. Suppose this is my ground level GL, and the precast means suppose I have precast a pile here. I will bring this pile here, and I will driven this pile inside the soil. That is the precast. And cast in situ means I will create a hollow space, and in hollow space I will placed a cage, steel cage, and I will pour concrete. So this is your cast in situ. That's mean we are casting the pile in the field. That is cast in situ pile. And precast means we have cast the pile in somewhere other places, and we bring it to the site, and we will driven the pile into the soil. Steel piles can be used as H piles or pipe piles. That is the large steel diameter steel piles. It is a high strength and used in marine and bridge foundations. And composite of piles means that is the combination of two materials like concrete or steel or timber plus concrete. And it is equal, depending on the project and the site situation, we can the material can be selected. The third category based on which the we can classify pile is the method of installation. So depending on the method of installation, we can classify pile in four categories: the driven piles or the displacement piles, bore or cast in situ piles, driven and cast in situ piles, and screw or helical piles. Now, driven piles are basically already I have discussed in the previous slide, that precast piles driven to the ground using hammers. That means somewhere else the pile has been precast, it is brought to the site, and this pile will be hammered and it will be penetrated inside the ground. So that is the driven piles. And bore and cast into piles, basically initially we will create at the site a hollow space, and in that hollow space we will fill with concrete, and we will cast into the pile. So that is the cast into the piles or the bore piles. And driven pile and cast into piles is basically, if we combine both the advantages, that's mean precast and cast into. Suppose in case of precast, I have painted the pile along this length, or suppose I have cast into the concrete base one, below above this I am penetrating the pile. So this is the combine of your driven piles and cast in situ. And screw or helical piles are basically suppose it can be reusable pile. So basically I have a ground here, so by screwing action I can rotate it and I can penetrate the pile inside the ground. And also by reverse rotating I can also withdraw the pile from the ground. So these are screw or helical piles. Helical means this kind of helical structure you can find along the surface of the pile. Now, based on the displacement of soil, we can classify pile as displacement piles and non-displacement piles. Displacement piles will basically call basically that when we are penetrating a pile inside the soil. So if we penetrate the pile inside the soil, then what will happen? It will laterally displace the soil. This is the surrounding soil present, and this surrounding soil will be displaced along this direction or maybe along this direction. So that is known as your displacement pile. And non-displacement piles are basically generally bored piles. That's mean we are not uh, displacing the soil, but we are excavating the ground, and by excavating we are creating a hollow space, and we are filling with the concrete or steel and concrete, and we are creating the pile foundation. So that is non-displacement pile. So that's mean that if suppose here is a soil is present, and if we want to penetrate this pile inside the soil, what will happen? Whatever the soil is present in this zone, as the pile will penetrate inside the ground, it will displace the soil in this direction. So that is the displacement pile. And if we are creating the pile or installing the pile by creating a board or the hollow space, and we are concreting it later, then it will be a non-displacement pile. Now, based on shape, we can classify the pile like circular pile, square or rectangular pile, H-section pile basically for steel piles, and trapper or uniform cross section. Trapper means it will be suppose like that way. The upper will be like at the end of the tip, it will be become narrower. So this kind of pile is known as your tapper section. And most common pile we generally use your circular pile, and these are basically made of your concrete. Now, based on the use or application, that's meaning which situation we are using, we can classify the pile as bearing piles, seat piles, batter piles, tension or uplift piles, and compaction piles. So bearing piles are basically used. That's mean it will bear something. That's mean it will bear the load. So this kind of piles are known as a bearing pile. Now, seat piles are used for retaining walls and waterfront structures. That means suppose this is a river. Now I want to construct a bridge in this zone. So what I have to do, I will install seat piles here. These are basically like anchor like this. So like seat are like this kind of seats are present, and they are anchored together. So it will create a hollow space like this. We anchor and we create a hollow space. We'll pump out the water, and then we can go for the construction. So these are known as your seat piles. Now batter piles are basically at an angle to resist horizontal loads. Suppose I have a suppose jetty structure, like suppose in a uh, offshore structure like in seashore, we are there's a wave action is there, lateral forces are there. So in this case, we will incline the pile like in that, install the pile in an inclined manner so that it can resist a lateral force. These are known as your batter piles. So keep in mind that the bearing piles, seat piles, these all are basically installed in a vertical manner, but batter piles are installed in a inclined way. And batter piles are basically used for your horizontal loads, but bearing piles are basically used for vertical loads. Now, tensor or uplift pile, that is resist the forces in tall structure or chimney. Like if we construct a tall structure like this, suppose I have this is a ground level, and I have a very tall structure like G plus 50 kind of tall structure is there. So wind load and earthquake load may act, so it will have a tendency to rotate in this direction. So if I have installed a pile here or in the foundation, so due to the rotation of the or the tendency of the movement of the building or the structure, the pile will, there is a uplift force will act. So if the building will start to move in this direction due to the lateral load, so the pile, there is a tendency of the pile to move also upward. So this is known as the uplift forces. So in such situation, whatever the pile you are using, these are known as your basically tension or uplift piles. That means if this is a pile, and if the load is coming from the superstructure, that is compression kind of loading, and the load is transferred to the subsoil. But if there is a uplift force is acting, that means tension is acting. So in such situation, we will use your tension or uplift piles. Now, compaction piles are basically densify the loose granular soil by displacement. That means suppose I have a whole ground here, and I will create a few hollow spaces. And suppose this is filled with your granular material, and here is a clay is present here. Okay, so we have gravels, we have sand like this, and we will provide your vibration so that the sand grains or the gravel grains, they will compact in a very dense manner. These are known as your compaction piles. So in that case, we are not using any kind of material like timber, concrete, or this thing. We are generally compacting the soil, and we are creating a zone where the strength of the soil will be higher. These are known as your compaction piles. So this is the end of the lecture 2, basically on the classification of the piles. Thank you.